should be a co-host now, and you should be able to click the record button.
Yeah, I started recording.
Thank you very much. Okay, always technical issues. Okay. So I share my screen here. So, do you see my screen?
Not yet.
See my screen now?
No.
No.
Then I try a window.
To run many other pods also. So that's the reason.
Do you see now a window?
No.
Uh,
You want to deploy even better. So the Hazel
what's happening here? Share screen, entire screen, share. Do you see something?
No. Looks like Zoom will force you to update.
Oh, yeah, it's exactly like that. There's a permission thingy. Okay, 1 second. I see it here. There's a button here, screen recording. The Chrome browser got updated, and now I have to give new permissions. Screen recording. Where is it? Screen recording. Privacy, security settings. Privacy. Screen recording. Google Chrome, where is it? I have to restart Chrome. 1 second to apply the permissions. I just joined.
So Alex, if you go to actual file, the ML file, and first one thing.
You are muted, Rani. Unmute yourself.
Yeah, okay. So can you see my screen now?
Yes, yes.
Yes.
So yeah, with the right permissions on my new Chrome, it works again. Okay. So we had last time a question about where was it? I made a note about it. Requested topics here. How can we change the time zone formatting in the web UI in the browser for the events and alarms? I think that was one topic which came up. So what you can do is you can set a property in OpenMS which tells you how the format should look like. So if you install OpenMS by default, it looks like this weird string, which is like the date, then you have the time and the time zone. And when you create a properties file, then you can define how that string should look like. And in that link here, date time formatter, you will find the format you can use to format the string as you like. Does it answer your question? You can create basically a properties file in that OpenMS.propertiesd with that content.
Great, thanks.
Okay. Okay. So that was one topic. And then I think we just go through go with you through the UI. And just to recap what we have talked about, like system object ideas and how that relates to each other. So that is basically the OpenMS instance from that OpenMS stack directory, which you find here. So I just spun up that Docker Compose stack. That's the UI for it. And I created 3 nodes, Linux 1, 2, and 3, which are basically the ones you see here in that README. These are these 3 Linux nodes here. And they have all SNMP enabled. And you can see that here, if you click on the node and you see here, that's the system object ID from Linux Server 1. Same for Linux Server 2. And for Linux Server 3, same thing. SNMP is detected. We get all the informations from provisioning. So provision D was able to talk to the SNMP agent with the SNMP community public. We have configured that with the configure SNMP community name by names. That's where you basically tell OpenMS what are the SNMP credentials to talk to the agent. We we made you aware that it is helpful to set the community first before you provision a node, because like provisioning itself gathers a lot of information from SNMP as well, such as like system object ID, all these parameters, IP interfaces, and SNMP interfaces as well, what you see here. That all comes from the SNMP agent during the provisioning. So if you would like to edit or to look at configuration files, there is a possibility to do that through the web UI instead of the local file system. If you go to the user, in this case, we just have an admin user here, and you assign the role file system editor to the user admin. Say finish, you have to log out and log in again. Then you have here a file editor in the info menu, and that gives you access to the configuration files. So that way you don't have to use like your local editor. You can edit the configuration files directly from the web UI.
So
Can you show me again the way you accessed to that menu, please?
Of course, no problem.
I missed the startup point.
Yeah, no problem. So first of all, you need a specific role on a user. So if you go to configure users and groups, you will see all the created or all the users in the system. There are only 2 users by default. So it's just main user. Then you click on modify, and you have to assign the role file system editor to that user.
Okay.
It's not assigned by default.
Okay.
By default, the admin user has just role admin, that's it.
Okay.
And then you hit finish, and you have to log out and log in again. It doesn't work like immediately. You have to
Okay.
get into the system. And then it will appear here in the info panel. If the role is not assigned, you won't see that entry here. It's just not there.
Okay. Okay. Good.
And that helps a little bit editing configuration files, or I think that might be useful.
And when we do the edition from that place, everything we are going to modify will be stored into the Postgres DB of OpenNMS, I guess.
So the configuration files, they live in the OpenNMS directory on the file system. I think it's by default like OpenNMS, and then you have the etc directory.
And we can lose them, so right? If the OpenNMS core pod will be killed, I don't know, for whatever reason, we will lose that information, right?
So it depends how you kill the stack. So when you run that stack from session 5 here, at that session 5, that's the compose file for it. You see here like these volumes, and there's also one volume for the etc directory. If you make just like a Docker compose down, then the volume still is persisted.
Yeah.
If you make it Docker compose down -v, then the volumes get killed as well. But you have to explicitly tell the down command to delete also the volumes for the database, Grafana, the config, and the data, which is like the RD.
Okay, and if we really want to make sure that we will not lose anything, the final solution is to copy the files externally from the pod with the docker cp command, I guess.
You can use the docker copy command, exactly, or you just make if you make just like a docker compose down, then the volume is still persisted. Or
okay.
So you just need to be aware of, as soon as you make it a -v, then I think you see that here in the docker.
Yeah.
Docker compose down, that's fine. If you make the -v, then these volumes get deleted as well.
Yeah.
Have really a fresh, clean install, so to speak. And you see that here where they are like mounted in. One is here, that's Grafana. Where's the core? Here's the core. And then you see here like data contains all the RD files, and the etc is the configuration. And with that editor, you can edit them directly. Okay, so looking a little bit at our configuration and how that looks like for performance monitoring. We start with, I think we can start with collectd. That is our that's the main service for which is responsible for collecting performance metric. And you will see already like there's a lot of configuration built in. So there's some configuration. So they are like organized in packages. Each package can have multiple services for data collections, and that is for Cassandra via JMX. So there's a configuration set for Cassandra. There's some configuration packages for VMware. And then there's for OpenMS itself. So there's like a self-monitoring happening. So so if you see like the service OpenMS JVM, there's also a data collection attached to it. I can show you that here. If we go to that localhost node, you see that here, that OpenMS JVM. If you click on that, then we see here there's a JSR 160 collector behind that service, and collectd collects performance metrics from OpenMS itself. It's basically here what you see in OpenMS JVM, the event logs. So there are a lot of metrics from OpenMS itself, which are collected as well, which is helpful in larger deployments to see how utilized is the system, how utilized is collectd with its thread pool, how utilized is PolarD with its thread pool, and things like that. And then we have the example one. It's the example one package, and that is the package which contains the SNMP service, right? So we have here our SNMP service. That's the 5-minute interval. So every 5 minutes we do a data collection, and the interesting piece is here that parameter collection default. So that tells basically, the package tells you basically where should I collect metrics from, and the collection set is basically what metrics should we collect. And then we have a second parameter for thresholding. So do you want to evaluate thresholds on these metrics defined in that collection set default? So
can we create several SNMP collections?
you
For
can
line of
create
code,
several
one
collections.
interval for router second.
Yeah, I will come to that later on. I think that is Craig explained me that that was a topic which you were interested in, about like dealing with different frequencies, collecting metrics. I can dig into that topic. I think it gets clear if we just go to like, just give you an idea how it works for the current configuration, and then we can make an example to change the frequency for different device. So that is the collection set, and on the bottom you will see here that tells basically for that service SNMP, it use the SNMP collector. So there's like that string here, like for the service name, it's just an arbitrary string. You can name it however you like, but you need to tell OpenMS, okay, for that SNMP string, what is the protocol you want to, or what is the underlying protocol you want to use for that service? And that runs the SNMP collector in this case. So you can create multiple services with SNMP if you want, and they can all run the SNMP collector. And that is basically the default configuration from OpenMS. You see that here, like all these services here on the bottom are using the JSR 160. That's basically the JMX collector for JVMs. And every time when collectd sees a service with the name JMX minion, collectd will execute the JSR 160 collector on that IP interface with the trying to fetch these metrics from that endpoint over JMX. So that is basically the collectd configuration. The tricky piece now is, where does this collections come from? Basically, where do we define which metrics we want to collect? So, and that is now the data collection config XML. So just to recap, that thing here is called SNMP here. For the SNMP service, it's called here, the collection set is called default, right? If you go into the data collection config, you see here on the top, that is the default collection name. And for that collection name default, these are all the groups we try to collect. That comes basically shipped with OpenNMS. So you see all these MIPs are already compiled in OpenNMS, and that's what OpenNMS can collect out of the box. Okay?
One data collection group does correspond to one vendor MIB.
So yeah, so there's
yeah.
now there's a that's now a very that's a very good topic. So if we look now in such a data collection group, right? You see that here in that data collection. So all these collection groups here for Aruba, BlueCat, and they're also Fortinet, HP equipment, right? They're all defined here in that directory. So if we look, for example, here in that HP XML, then you will see all these groups, and these OIDs will collect it only if the system object ID matches a certain pattern. So that means we only collect all these OIDs only if the system object ID from a node, if we go to that node, we collect only these metrics when the system definition matches, right? And it can be like an explicit match, like this one here, or it can also be a mask, which means it can be like associated with any device of a certain class. It's not very easy, but it's a very powerful topic because it allows you to assign various metrics to a class of devices depending on the system object ID string. So let's look, for example, in the MIP2 XML. So standard MIP2 is probably a MIP which is implemented by many vendors like HP, Network Gear, Cisco Network Gear, Juniper Network Gear. They all support the standard MIP2. So it wouldn't make sense to define for every device or for every vendor the same MIP object IDs. It would be enough to just define it once. And then you can say, okay, every device which matches the enterprise MIP, even if it's like a Cisco device, right, or an HP device defined by the enterprise MIP, everything which is part of that tree will collect the MIP2 metrics as well. So you can basically build up like a set of metrics which are applied based on the system object ID of the device. So that way you can you only have to define these MIP2 metrics once for every enterprise SNMP agent. So if you look like that enterprise MIP, so basically just this piece system object ID string needs to match to get these metrics. And then you can be more specific for an HP printer, for example, and apply more specific metrics if you have like a printer, right? And then you would include here different metrics.
But in this case, those masks will work in parallel. So both
Yes,
enterprise, for example, and yeah, it's
yeah.
not an exclusion. Logic is
It's not
both.
an exclusion. It's like it's basically accumulating all the metrics depending on the system definition and the masks. What metrics get collected from OpenMS? So it's not very obvious, but it makes a lot of things very powerful because you only have to specify for like an enterprise SNMP agent, you have to only specify it once and that's it. If it's a Linux device, it will match. If it's even if you add a brother printer and it supports the enterprise MIP, the system object ID is part of that enterprise tree, basically. It will fetch the metrics in the same way. Okay.
Ronnie, can you just summarize the hierarchy of the configurations file as and then the structure which you just now explained? Miss, just summarize maybe once more.
Yeah. So there's like a so it starts basically with if we start with collect D, I think that's the easiest way to go to pass that route from collect D, where you have like the service, and associated with that service SNMP, there's like a collection set, which is here in this case default. That collection set default is defined in the data collection config XML, which is here. That's where we look that up. That collection set includes all groups you want to support, all metrics you want to support, basically. But in each individual data collection group, you define on which system you want to apply the device based on the node system object ID.
Okay. So we do this from the backend, or does any UI used for this?
What is you mean? How you configure that, or what is the question exactly?
Yes. How exactly we configure? If
There's
there is
the
any
only
UI.
way to configure that is over the XML files.
Okay, only
You have to do that through XML files.
Okay.
There's no other way around. In that relationship here, I try to, if you look into that slide here, that is basically, show more pages, where was it? I tried to, that one here. So that's basically like the mental model. That collection set default has all the collection groups with the OIDs. It has the system definitions in there. That is basically really about on which device class should I collect what SNMP OIDs and tables, if you will. They are assigned to an SNMP service and combined with the system OID that creates basically the data collection.
And
So that-
Ronnie, when we make any changes to this definition, collection definition, is it considered automatically, or do we need to restart any services to make it effective?
So you can change, you can create new data collections on the fly. As soon as you create them here, they will be applied.
Okay.
There are some there's some pieces in collect D which are not applied immediately. If you change, for example, the interval for the data collection, then you need to reload collect D.
Okay.
You can do that through the Carafe shell, for example. You don't have to restart the whole OpenMS system, but you need to reload the collect D daemon. And you can do that via the Carafe shell. So you could do something like reload daemon collect D. That would be the command here. Can you see that?
Yes, yes. Thank you.
So that would reload daemon and then collect D.
Okay, thank you.
Okay, so that is related to collect data. So how does it look like? So if you look like in if you look in OpenNMS, we go into that core bash. So can you see that directory here on the bottom? Make that a bit bigger here. Do you see that here? So that is the directory in the container from OpenNMS. This is the etc directory where all the configuration lives. It's basically the same as here in the UI. And in share, there is a folder called RD. And we have an SNMP folder. The foreign source comes from provisioning. We call it Linux server, and then you have like Linux server 1, for example. And then you see here the RD files, which are collected. So for every metric which is specified here in the data collection file, I think it's TCP, that might be the MIP2, comes from the MIP2. Search TCP out. So you see that here from the MIP2 TCP MIP, all these metrics here create an RD file on the file system. So that's like there's one for every metric you collect, an RD file is created. So looking into that folder tells you basically, does my data collection work? So if I see where is it? Linux 03.
So the metrics are stored both in that folder as RRD files and also, I guess, in Postgres DB, right? No,
there's nothing.
Only in that files.
Yes, exactly.
Okay.
So that's the time series storage, basically. Yeah.
Okay.
And if you use something different like Mimir or Cortex or any other time series storage, you won't have these RD files. They won't be stored then on a dedicated system. But the mechanism is the same, basically.
But it's not a time series DB here. Everything
it's not as time series. So yeah, the time series storage, it's RD tool, which is not really it's not really a database, so to speak. It's just like files on the file system. I wouldn't call it like a real database. It's more like a ring buffer, so to speak.
Okay, so in fact, OpenNMS only stored the alarms, the traps in Postgres, but for the metrics, it is stored differently, right?
Exactly.
Okay.
Yeah, that is an important piece because like it helps also if you scale or if you design a solution, then it depends a little bit how many traps do you get, how many syslog messages you want to receive. That defines basically how your Postgres database need to be sized, because all these events go into the Postgres database. Also the inventory, like if you create a node, you add services, all that that information you see around a node, or like the topology is also stored in the database. But time series data is completely decoupled and is stored in on the file system in RD by default, and you can replace it with other technologies like Cortex or Newts. Yeah, there's some other ways to deal with that. RD files are really easy to deal with because it's just really very simple in the file system. And because they are like structured as a round robin file or as like a ring buffer, they cannot outgrow your disk, because like if you look into RD files, each RD file has like 38 kilobytes here, and that's it. It never gets bigger. So there's like when OpenNMS fetches the first metric, it creates the RD file, and it basically allocates already the whole disk space for a given time range.
But when this file is filled totally, what's happened? We will
You drop it.
we will lose the oldest
Yes.
metric.
Yes.
So in that case, what's the
So that's
the duration of a metric?
Yeah, exactly. So that is now that's a very specific topic which only applies to RD tool. So you need to be aware of that. So it's because there's that's a benefit, because you can really easily calculate how much disk space you need, and it will never grow bigger, right?
But I guess we can
So in
change
fact,
size
if I
of the
will follow
file.
you, we don't need to, we don't have to consider OpenNMS as a storage tool. In
Okay.
fact, the storage, I guess, the storage of the metrics should be done by by the targeted application that will collect these metrics from OpenNMS. I guess.
Okay.
No, am I right or?
It depends a bit how you. I think what I've seen, like in that TMIP integration, it looks like you store the time series data yourself.
Yeah.
Yeah. So I think then it is not very. It's not. We don't have to dig too deep into that topic. It's just I just want to make you aware of when you use RD tool here by default. That is how you define basically how that RD file looks like. So this step size means you have like a 5-minute buckets. Every 5 minutes there's a bucket, and you have different tracks, and you have here multiplier, like that means like 5-minute buckets one time times 2016. That gives you basically a time range where you have 5-minute accuracy time for the metrics.
Sorry, I think there was a question from my colleague.
Yeah, please.
No,
Sorry for the accent.
you already answered the question. That's what I was exactly asking for.
Okay.
Yeah.
Changing of the sizes. Thank you.
Yeah, no problem. So with RD tool, there is it's really predefined how long do you want to store metrics in a certain resolution. So like a 5-minute resolution is 2016 steps. So you have to calculate 2016 times 5 minutes, and then you have a time range which gives you exactly 5-minute time. 5-minute time resolution, and here it gets always like that's an hour, like 5 minutes times 12 is an hour, so you have 1 hour resolution for 1488 steps, so you have to calculate like 1 hour times and then gives you kind of a time window where you only have like a 1 hour accuracy of your time data. So it gets always basically longer, but also more blurry, so to speak. So that is basically how that RD file here is defined and how you get to that 38 kilobytes. And it predefines already for which time window you have a certain accuracy in your time series data. So you can store basically a year worth of data in that file, but it loses precision the older data gets. And that is only applied to RD tool. If you use anything else like Cortex Mimi or your own solution, you have to deal with that on your own. It's not, you don't have to deal with that. So the reason why I'm talking about that, because there's a relationship between like how you define these RD tools on the file system. You see that here, like you define a step size of 5 minutes for your storage, and your collection interval, they need to match. That is when you use RD tool, that is important. So that SNMP collection interval for 5 minutes need to match to your RD storage configuration, that the step size exactly the same. Otherwise, you will basically fill your RD storage with wrong intervals, and then your visualization will be broken because like,
Ronnie,
yes.
this okay, I understand we need to align these two numbers from different files. Okay, I understand that, but this is not controlled by the OpenNMS UI. There is no control for that. Okay, no to make sure that everything is consistent. No, there is not this from the UI. Okay.
There's nothing. You need to know that relationship between how much metrics you collect and when you store that in RD files. So that is so that's the reason why I'm at least make you aware of that problem. If you don't use RD tool in production, then you don't care, right? But if you play around with it locally, and you change the interval here from 5 minutes, for example, to 10 seconds, right? Which is not a big deal. It's easy. You save it, and then you get every metric every 10 seconds instead of 5 minutes. But our RD tool definition is expecting every 5 minutes a new value. Right?
But do we have the choice? I mean, we have to use the RID tool. There is no other alternative than using it.
You have alternatives.
Okay.
It's just like from it's just very convenient to ship it with like RD tool, because you don't rely on an external Cortex cluster or a Mimir cluster or Cassandra cluster to store performance metrics. When we use RD tool, like by default, it's just created in the file system. It's very easy and convenient.
Yeah, I see.
Because there's no complex service you rely on just to get metrics.
So you recommend to keep that default?
I wouldn't. It depends what you try to achieve. So RD tool with like modern disks, you can go really far. So because it creates probably a lot of I/O on your system. Like with SSD, you can collect a lot of metrics these days with modern SSD drives. But I think if you would like to be a bit more flexible about, like, for example, changing the polling interval easily, or scaling the solution to more for more performance, then I would suggest using something like Mimir or Cortex as a time series storage. because it gives you then much more flexibility. The downside is you have to maintain a Cortex or Mimir cluster. So you have to make a decision kind of from your use case, what makes more sense.
Okay. Okay.
So the RD decision is just because it's like it's very convenient, and you don't force the user to maintain a Mimir or Cortex cluster, right?
Okay.
Okay, so like that data collection part, yeah, data collection config here, that step size here needs to match the collection interval. Okay.
Just can you do can you dump one RD file here just to have an idea about the content of that file? Can we do a cat?
There is you need to you cannot read it.
It's a binary storage.
Yeah, you have to use there's an RD dump tool. I can add that into, I just make a note. I can make, it's pretty much similar what you see when you make a REST API call. Dump. Yeah, I think we need to install the RD dump tool. So there's a command line tool for RD, which is which can give you the metrics onto the CLI.
Okay, this utility does not come with OpenNMS. Okay.
No, it's not installed. It's a package from the RD tool suite. So RD tool itself is an own open source project, which is all about persisting and visualizing performance metrics. We haven't talked about the visualization part yet. We're just talking about like persisting them on disk. So that's how they come. They are collected from collectd and they are persisted on the file system, right? So for example, if you look like here in that MIP2, for example, so here like typical interface metrics like in octets, out octets, right? So, and they get basically persisted here on the file system. So the visualization part. So that is, RD tool does both things. It's taking care of like the storage. It does also take care of the visualization of it, like rendering a graph. So if you look like into like that node 3, for example, resource graphs. Let's see what we have here. So TCP open connections, all these metrics we collect over SNMP, or here from Q statistics, for example, right? All these graphs are consistent with multiple metrics, right? You see that here. So you need to specify somehow which metrics you would like to visualize in one of these graphs, right? And that is also handled by RD tool. And that's where these SNMP graph properties come into play. So you see here now all these graph properties define how you would like to visualize them. So if you look like into the MIP2, for example, then you see all these reports here. And that's so the that's RD tool graph templates. It tells you basically what metrics you would like to visualize in octets, out octets. Then you can use arithmetics to multiply it by 8 to get bits from octets, which is bytes to bits. So you have a bit metric. And do you want to have a line graph, an area, the color? All that stuff is defined in that graph definition here from RD tool. So again, that's just required if you really want to use the web UI from OpenNMS to visualize these graphs. That's what you see here in these resource graphs in the web UI. I'm not sure if that's necessary or if that's required in your environment.
I don't know for the others, but in my case, I will not really use the OpenNMS UI. In fact, I will just use OpenNMS as a feeder of alarms and metrics for my application.
So I think then it's very safe to say you stop basically on the whole data collection part. You don't care about the graphs. If the graph's not there,
the graph is interesting, but I mean, personally, I will use the default graph. I will never try to customize them.
The interesting thing is if you, for example, just to give an example, what happens. So let's say we go to the MIP2 configuration here, and we add here a new metric. So let's say the interface, I would like to have another MIP object OID, and then we find in our MIP there's another one, let's say here 22, same thing here. It's not called out instant, it's my metric, right? My metric, so it's a counter. So if you never specify a graph which uses that metric, you won't see it at all. It will be persisted. It will also be forwarded to Kafka or to any time series storage you use, but it will never be visualized because there's no report for it. Okay.
Good to mention.
That's important to know. That's so there's so if you don't specify a report which visualizes this metric, you won't see it in the UI. But you can collect it on the file. It will be collected and persisted on the file system, or will also be sent to the Kafka producer as a metric. That's not a problem, but like it's really like the visualization part and the collection part is completely independent.
Okay.
But I think that's an important thing to know because what might happen is you create your own MIP or you want to make a data collection, you add your metrics, and you won't see it in the UI immediately. And that's the reason why you basically, if you look into the file system or you query your time series storage, you will see it. So, but it doesn't mean necessarily it's automatically shown in the web UI. You have to create a specific report which uses that metric to visualize it. Okay, I just clicked here reset and removed it here. So it means basically we don't save the file here. Okay.
Ronnie?
Yes.
In the resource graph, I noticed there's this collection time period, right? If you go to the resource graph, in the UI graph, OpenNMS. Yeah, and if you click the upper right lightning button, yeah, when you click on this, there was this preference, right? Like we can choose 10 seconds or 5 seconds. Is this also related to the RD tool correction period?
So it's not related to the RD tool collection. That's
so this one is just for the purely on the visualization part.
Exactly.
Is it?
Yes.
Okay.
What it basically uses basically the same graph template for the visualization. It just fetches the same metrics ad hoc every 10 seconds and just shows it in the UI.
Okay. Because I'm not, I thought that this is somehow relates to the RD tool, the millisecond we need to configure how often we collect the data.
Yeah, it bypasses collect D completely here. So
Okay.
that's a completely parallel path to the agent. It just just fetches exactly the same metrics required to build that graph.
Okay.
In real time or near real time, or however you call it. And when you look like here, the data is just like so these raw data you see here, which comes up like every 10 seconds, is just for the time you have that NRTG running. If you make the same thing here, you get it. You can query the whole RD file if you want to. That is, you have here with that graph here, you have access to the whole RD file.
Okay.
So if you pick here like last year, for example, then you would see like a whole year. And if you go to data, then you will see exactly all the data from a year. We don't have the system that much, so it's not running for that period of time. But if there would be like metrics, you would have like 1 year of data here. Okay.
Yep.
Okay. So, okay, so that's the visualization part. Another option is using something different like Grafana for the visualization. Then you don't care about RD tool at all. So, because then you use like Grafana as the visualization tool. So, but I'm not 100% sure how deep you need to go for the visualization, because I think you forward that to your own system and it seems like you visualize it on your own system, so to speak. I think if you want to just we can make a dedicated session just about like Grafana or anything else. Otherwise, might get too deep in topics you might be not interested. But okay.
Sorry, Rennie.
Yes, no problem.
I just need to have a technical break. I will be back in 2 minutes.
Yeah, sure, no problem. Yeah, then just we make a break for 2 minutes. If anyone else has some questions in the meanwhile, please feel free.
Ronnie, from the events UI, if I have to remove or delete the events, is it possible? Is there any options?
You mean for the event UEIs?
Yes, events or alarms. I want to clean up before starting anything else or before trying out next event test. So can I delete or clean the existing events?
So what you can easily the easiest thing is just delete that database.
Okay.
Just basically tear down the whole compose stack and delete the database and just recreate it from scratch. What you can also do is you can use like a Postgres SQL command and make just the delete events.
Okay.
And that will get rid. So if you delete the events from the Postgres database with a so you just the statement would be just like delete from events. That's it.
Okay. Got it.
And that will delete all events and also all related alarms to the events, and also everything which is related to the events will be deleted as well.
Mm-hmm.
Do we have some events limitation or alarms limitation in the database? Or just
Postgres will
database
be
that just keeps growing?
yeah, it's the Postgres database will be the limiting factor on that.
But we cannot tell it, for example, if we have 1,000 of the alarms in the database, oldest 3 weeks
Yeah,
alarms.
so like it depends how you tuned and configured your Postgres database.
So it's entirely in the Postgres, no
That
any
is
features for trimming in the OpenNMS.
so you can do like in OpenMS, there are some mechanisms where you can do some like event garbage collection, if you will, to say delete all events older than 1 year or 6 months or something like that.
So it's possible.
So there are ways to that's basically happening in vacuumd is the configuration file. There are some you will see that vacuumd configuration. You see here there are some cleanup jobs running periodically to get rid of certain things.
Okay, great.
So there are some ways to purge old data. Yeah. But like the really what takes, so that makes sizing a little bit different or complicated, because usually it's really hard to tell how many events you get and how your Postgres database hardware and the tuning of the Postgres database needs to look like to cope with these workloads. So there are a lot of parameters involved to make that happen. So that makes it a bit complicated. And by default, like the Postgres database, if you look like at the Postgres database, like when you just install it on a plain Linux system from the packages, it's mainly very, very defensive configured. It just uses like 128 megabytes of RAM. It's very small, like for very small workload configured. There is a tool called pgtune. I think that might be worth noting here. It allows you to pick like the Postgres, some kind of Postgres parameters. And for OpenNMS, you would have a mixed type application, and then you say, okay, my Postgres database server has 32 gig of RAM and maybe 16 CPUs, and I would like to have 200 connections. It has SSD storage, and it will generate you a configuration which uses that hardware requirements most efficient. So that can help you to figure out how you need to configure your Postgres instance to really use the hardware you.
Can you push the URL in the chat?
Yes, no problem. Yes.
Thanks.
Chat here. The message just goes to, for whatever reason, Sanjaya got the message. I'm not sure why I can't send a message to anyone.
Yes, I received the message.
Okay. I can drop the link into I just make a note here in that README, and then you get it when you sync the repository if you want. There was a hint section somewhere. Hints here. I'll just drop it here. PostgreSQL. pgtune. So then you have it in the I think you forked from Greg's repository again. C, that's the one. So, yeah. So are we back? Everybody's. So session 5, readme. So I think then we go to the next topic, which is yeah, we can make an let's make an example how we can change the collection interval in the config from like 5 minutes to 10 seconds, right? So we just make that here in that example. So we need to find first our collect-D configuration, figuring out where our SNMP service is. We make here 10 seconds instead of like that's in milliseconds. I think the worth noting, so like that that editor is also kind of so if you make mistakes in your XML file, it will complain. So there's kind of validation here happening. I think that might be helpful.
Okay, so here, right above, we will collect this metric every 10 seconds.
All the
Correct?
metrics defined in the collection set default.
Okay.
Everything which, so, and there's like, yeah, everything what we specified in that default collection set in the data collection config XML. So
okay.
Every 10 seconds, collection set default, that's default, all that here, every 10 seconds. From that SNMP, everything every 10 seconds. And you should see that already here. If you click on the node here, what I showed you yesterday is SNMP, right? There's now 10 seconds here instead of 300,000. That's the collection. So that's the collect-D. So that's basically what comes from the collect-D configuration here, right?
What is this node?
That's
what is it's a node that supports an SNMP agent.
Exactly. It comes with this. It's defined in the stack here in that compose stack. If you look into that, there's like Linux 1, Linux 2, Linux 3, and it's just running the NetSNMP agent in Docker. And it has its dedicated IP address. So it simulates basically a host, if you will.
Okay,
We can
so
use
it means that here we collect the metrics from the Linux 03 system, right?
All of them. 1, 2, and 3.
Yeah, but okay.
Okay, yeah. Every 10 seconds instead of 5 minutes.
Okay.
So now comes the part where our RD tool problem exists, right? Because we have now RD files created with 5-minute intervals, not 10-second intervals, right? So that's the reason why we need to go into the data collection config. And you need to change that here to 10 seconds every step. And now that's the sad thing. These RD files are already created. You need to delete them to apply these changes. So OpenNMS has to recreate these RD files with the new step size defined here. That's the downside of using RD files. You won't have that problem with any other time series storage. Because like that's how RD tool is created or is designed. It basically it creates a file on your disk with exactly these parameters, and if you change that afterwards, the only way to apply the new changes is delete the file. You have to delete the files and recreate them with the new parameters. Okay. So we delete here Linux. And then we wait for the next data collection, and then it will be recreated. Okay. So, and yeah, that is exactly the point where it is required to reload. So if you change the interval, OpenNMS won't pick it up immediately. You need to reload the collectd configuration. The password for the SSH is exactly the same as for the user. And then you see here the files for each node are created. And then you have like a 10-second collection interval now.
Can you please push the command about the reload the daemon? Collectd?
Here in the README.
Okay.
It's if you go in session 5 in that README, then you see that here.
Yeah. Okay.
So yeah, before we're digging into the next topic, which will be thresholding on these metrics, have you any questions on that or anything?
One thing, what happens when the RD file is full?
They don't. So they basically, you can imagine it's like a file with like predefined buckets. They get filled, and when all buckets are filled, the last ones will be dropped.
Oh, okay.
So it's just like the last ones basically fall out, so to speak, or get overwritten. You can see it like if you see it like a ring.
It's a rotation.
You have a rotation.
Okay.
So that makes it very interesting because you can really pre-calculate the storage you need for your for the data retention and granularity, and it will never use a bit more, right? But the downside is if you want to change it afterwards, then you have to delete the files and you have to recreate it, and you lose all the data you have collected. So,
but the data, is it not stored somewhere in OpenNMS, the collected data? Or it's all stored in RD only?
By default, it's stored in RD, but you can use you can also use something else if you want to.
Okay.
And that is what I've talked about here in that PDF. session 5, performance management introduction. This is basically this part.
Okay. This part, right? Yeah. Sure.
So RD tool is the default when you just install OpenMS from the packages, but you can also install a Cortex plugin or Mimio plugin or Newts plugin, and you can also enable the Kafka producer, which also puts the metric onto a Kafka topic, which you can consume from your own application later on.
Okay.
Okay.
Yep. Understood.
Okay, so then we look into thresholds. Yeah, thresholding is we have like in OpenMS like basic thresholding, like high thresholds, low thresholds, and also like change thresholds. So if a metric make like a consecutive measurement, and then one measurement is like far off a previous value, right? So you get like a spike or something like that. Then you can apply a threshold there as well. So thresholds can be configured through the web UI. Configure thresholds. You see we have some predefined thresholds as examples already. If you look into, for example, like the net SMP configuration, then you see like there's like a disk percent threshold already defined. So every disk which is more used than 90%, a threshold event will be created. A high threshold event will be created. These are for the nodes, like the inodes on the disk, same thing. And then you have here the trigger. So a threshold is basically defined by a value, a rearm, and a trigger. The value is pretty obvious. It's basically when the threshold is exceeded. And the rearm value tells OpenMS when it gets back to normal, to have a way to represent kind of, yeah, state, if you will. So that you can raise an alarm, okay, exceeded, and then somebody freed up the disk and it goes below 75%, and then the alarm gets cleared because it got under the rearm value. Does it make sense? So the trigger means you need to have at least 2 data collection cycles exceeding the threshold. So if we have just one measurement going over 90 and the second has just 85, nothing happens. It just means like you need 2 consecutive data collection cycles exceeding the threshold, then the event gets fired. So that way you can make it a little bit less granular, if you will. Because sometimes, especially if you have like CPU usage, which is like spontaneous spiking or network bandwidth, you don't want to trigger an event immediately when it exceeds a certain threshold. You want to just send a threshold if it takes a longer period of time, right?
So here, Ronnie,
Yeah.
if we have 2 consecutive values above 90, OpenNMS will trigger an alarm.
It will trigger an event first. On that event is an alarm definition, and that will create an alarm.
Okay.
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 And it's the same thing if you look into, we can look into one of these events in a minute. It's exactly the same thing what you've configured with Greg yesterday in the event definition and the alarm definitions, and also what you made with the traps. It looks the same.
Yeah, because I guess that when you mean when you say that it will trigger an event first, I guess by event you mean an SNMP trap, probably specific SNMP trap about
no,
about
it's not an SNMP. So in OpenMS, so what we have here is I can show you that here maybe on that slide, Tim. So what we have here, where is it? More, where's the here? So what you see here on that, so all these daemons are on the event bus in OpenMS, which basically processes these events, like the OpenMS event definitions, what you define. So collectD will create an OpenMS event directly. In SNMP trap, the trap comes in, the trap daemon will convert it based on the MIP to an OpenMS event and sends it on the bus and persists in the database.
Okay.
So we normalize basically various protocols to these OpenMS events. That's why you see all these event configurations all over the place for syslog, for SNMP traps. That's basically where we use like very protocol specific messages and turn them into OpenMS events. And the daemons ourselves, like collectD or polarD, they just create native OpenMS events like a high threshold exceeded or a node loss service or a node down event. So they create the events natively because they know what to do basically by themselves. The trap daemon or the syslog daemon, they need some instructions how to map an SNMP trap to an OpenMS event, or how to map a syslog message, or how to parse a syslog message to make it an OpenMS event. Does it make sense?
Yeah, definitely.
Okay.
Thanks.
Yeah, no problem. It's not weird concepts. I totally get it. It's not super easy. But I think if you get like where the bits piece.
And Ronnie, just to finish on that example that you are currently displaying. Okay, so we will generate an event when two consecutive metrics will be above 90. And we will get a clearance event, I guess, when two consecutive metrics will be below 75, if I will understand.
Yes.
Right?
Exactly.
Okay.
Yeah.
Okay. Thanks.
Is this information stored in some XML file or it's in the
Same,
database?
yeah. It's if you look into, I can show you where that is. It's here in. There is a threshold XML that's persisted in the file system. It's not in the database.
Okay. And the data source and source label, a data label are coming from the MIP and should match exactly what is in the MIP, right?
That is driven. That's exactly when we can create a threshold in a minute. That's exactly what is driven by the collectD configuration. So if you look here into the disk index and the disk percentage, that is from the, where have we looked into net SNMP. So if we go to the net SNMP data collection, I think that's a super complicated piece, but I think if you get the idea where it comes from, it makes it a lot easier. So if you look like that's the disk index here. So we haven't talked about like going through tables. So if you have like SNMP tables, OpenMS has like a resource type for each. So a resource type means something like network interfaces or disks in a system or CPUs. So you have like a resource, but you have multiple instances of it. And then you need to iterate through the whole table, and that's where that resource type comes into play. So, and you can have like you can use a label for how do you want to identify each line. So For the network disk, you have, for example, like a description, or in this case, like the path, where's the mount point in Linux, to identify the disk. And that is specified here in that resource type. And when you see, and here is basically for every disk, these metrics will be collected. The disk path, total disk size, how much is available, used, and the value in percentage. And that goes basically through a whole table of disks. It's not just the slash, or not just one particular disk you collect, we collect all of them. And that is the reason why you need here in that threshold, you need that disk index and you need a label. So when we trigger the event, you would like to know on which disk was this threshold exceeded, right? Because you have like 10 disks in your server and you would like to know which disk was over 90%. And that's how you map the values into the event.
Yeah, but this file netsnmp.xml was generated in the loaded MIP, right?
It comes, yeah. You need, so so basically when you get a new device, like whatever HP Pro Curve networking gear, and it has some specific parameters you would like to collect, which are not default, then you look into the MIP, figure out what resources you want to collect. You extend the data collection with these new OIDs, and then you can create thresholds.
Okay, thank you.
And there are basically two types of metrics. One is like these tables where you have like multiple disks or multiple CPUs on a server, or you have something like metrics which only exist once on your system. For example, like the CPU usage in total, right? That's a metric which is like across the whole system. That is, I can show you that here, for example, here on the Linux server here. So that's when we talk about like these node level performance data. These are mostly like metrics which exist only once. So there's only one CPU usage, right? There's only one memory usage, but for network interfaces, there can be multiple ones. So there can be like multiple instances of a network interface in the system, or like storage. Here you see there are many storage endpoints provided from the SNMP agent. So that is where these data source type comes into play. The data source type is necessary when you collect metrics from a table, like interfaces or disks. And when you say data source type node, then it means it comes from, it only exists for the whole system. There's only one metric. There's just one instance of that metric available. Like the load average, for example. Here's there's a high threshold by default for load average. There's only one load average metric on a whole node. It's not, there are not multiple instances of it.
Ronnie?
Yes?
Let's imagine that we have put in place everything to collect metrics from, let's say, from a specific node.
Mm-hmm.
We think that everybody was set up correctly in our OpenNMS system, but finally, and unfortunately, we do not collect any metric from that node. Do you have a nice troubleshooting hint or guide to share with us in order to to troubleshoot step by step and to eliminate the possible root cause until reaching, of course, the real root cause. Do you have some troubleshooting step?
So what you can do, so what makes it, so what you probably start with is you can use the, there's a caraf command which triggers, which can trigger a data collection immediately.
Good.
So you can say like OpenNMS. So it is all the, if you type here OpenNMS and hit the tab key, then you see all available commands. Graph shell. So there's a OpenNMS collect. So if we say -help, so what do we need? We need the location. Yeah, and
so the location is a subnetwork typically.
It's the location here in OpenNMS. It means like when you provision a device. Yeah, that is that.
Okay.
If you don't have a minion and you do everything is collected through the core system, then it's called default.
Okay.
I don't know why. It seems like OpenNMS people have a very tendency to call everything default, which makes it very complicated to, because like you have a default location, you have a default collection set, so it's very confusing. But
so here the column is named minion location.
Exactly.
But in fact, the default value doesn't mean it is collected by a minion. It is simply collected by OpenNMS core, right?
Exactly. Yes.
It's a bit confusing, yeah.
Which makes it even more confusing that it's here called minion location, which is very interesting. I think that's something we need to change.
For sure.
So okay, so that will definitely be a bug report. Okay, so so we say here OpenNMS collect location default n is the node ID or foreign source foreign ID if you want. So we take the node ID. It's sometimes easier just having the node ID. Node ID is 4 in this case. And then what do we need as well? Persist node. Do we need anything else? The collector class we need. Collector class is this. And the interface, which is 642.34. So, and then you see basically all the metrics it tries to collect from that node.
All the metrics that we are supposed to collect, right?
Exactly, yes. And then you would have like the collect D log on that as well. So if there is a in the log directory, so every daemon has his own log file. So collect D has a specific log file, and it basically updates with that updates just with every collection. So every 10 seconds it gets up. Like here's, you see that 11:44:16, and that's 26 here.
Can you show me again the command that you enter?
Sure.
Yeah, on the left.
Yeah.
Yes, that one. Collect D.
Yeah, what I can do, I just drop it here into that same README. I think that might be easier. So read me here. There was a hints. Network data collection for nodes. So that was missing here as well. SQL. Okay, so so that's the tricky part in threshold. So the most complicated part in configuring thresholds is figuring out what are the metrics I need to configure or to apply the threshold, so to speak. And what you see here as well, you can do like calculations. So you can say like load average divided by 100 divided by the number of CPUs times 100 gives you a percentage value. So you can have arithmetic expressions in a threshold as well. And that is basically the difference between an expression-based threshold and a basic threshold.
Sorry, what is the difference between these two kind of threshold?
You can make arithmetic expressions.
Okay.
Here you do the threshold on the value as it comes from the agent, and here you can apply a arithmetic expression and calculate it to percentage and apply the threshold against a percent value. Instead of like
excuse me, Ronnie, these expressions are driven, are in some way guided, or you have to know in advance how to express them? Because what is really complicated for me is this.
Yeah, so you need to, so if you make like for example, if you want to have a threshold for the memory in percentage, like that's here the swap space, you need to make that calculate, you need to know how to calculate it. So you need to know, okay, I need to use the memory available in swap and the total swap to make and calculate it to percentage to make sense out of it. There's no one who can take that away from you right now.
So there is no way to be, I mean, the one that you are showing is a division. So, okay. But if there are more complicated regular expression is operator that can be used.
So yeah, so regular. So there's regular expression. So that's really just about like arithmetics here.
This is okay. Yeah.
What you can do here is, for example, on maybe you have a disk or you have like 20 disks in your server. Would like to apply a threshold only on a specific disk.
Yeah.
Then you can use that regular expression to filter on a specific disk path, for example.
Exactly.
So that gives you a way to apply a threshold just through a subset of
some instances.
Instances of a table, so to speak. Yeah.
Okay.
So it becomes, you see, like, and it depends about what do you pick as the data source label. So the the regular expression is basically applied against the NS disk path, which is specified in the data collection as a string, right? So you need to know pretty accurately how you collect the metrics to configure the thresholds. That makes it super weird. I totally get it, because it's not very transparent. There's no way to the only thing what you see is like here, if you click like here, the data source types, they show you the table from all the data collection configs we have, right? But to get like to that, there's no help here, right? So there's nothing. So you have to look into the file to figure out what is the label for it and what is the metric.
Data source, the label.
That makes it not very easy. That's
no, it's not easy. Sorry.
That is because there's no. So you, I mean, that makes sense. That's you can get an idea. Okay, I specified that this table index somewhere in the UCD MIP maybe, or here for the HP whatever HPUX file system, right? But then you need to look into the data collection file to figuring out what is the disk data, how was the data source label named, and what is really the metric I would like to apply the threshold on. That makes it super weird. I totally get that.
So let's try.
Yeah. So that is, but I just that's why I need to spend a bit time here because they are all somehow related to the collectd config. It all comes back. How do you collect the metrics, basically, in the end of the day?
For example, there was some metrics that I have to manage. I didn't manage that was related to high availability of a cluster, an equipment that is in cluster. So there is a var bind that says, okay, when this is in high availability or not, and I didn't manage to do it. It was very difficult. I don't know if I can give you the example. I don't know if there is time. Not at the moment. It's too late. But
I think what definitely could make sense if you just try simple examples first.
That's I did. For example, if speed or something like that.
Yeah, something like everything which is already collected. So, or just go use the default threshold here, and just fill up a disk with on a virtual machine, right? Fill it up with DD or whatever. Just create a large file and see how it works. Change the parameters here, and then apply other thresholds if you want to, and work your way up there, because it's not very obvious how all that stuff here relates. So if you create a threshold the very first time and it works, I think you will be 1 out of 1,000 people probably. But in general, it's pretty, because you can make like thresholds like on regex, so it's kind of powerful, but it's also not very easy to deal with. Yeah. Okay. If you want to play with thresholds, so what you can, when you have that stack, it's also documented here in that section. For thresholds here, that's the command. So you can use a tool called stress. So in that Linux 3 system, you can install it. Because it's not in that Docker container image, that stress command is not there. It simulates basically CPU reload, if you want.
Okay. Okay.
So that command will install it in the Linux 3 system.
Mm-hmm.
So now it's in Linux 3, you have that stress command available. And if you run this command here, it simulates basically a CPU usage of 55%.
Okay.
So if you look in Docker stats, then you see on that Linux 3 system here, the CPU usage goes to 50%. Idle somewhere around. And if you stop it, it goes back to 0.
Mm-hmm.
So that way you can play with CPU usage threshold, for example, pretty easily. Makes sense. We can try it with 100 and see if we can get the load to a value which, because there's a default threshold here, right? With configuration, configure threshold, net SNMP. There's a load threshold. We make that here a 1. So it's quicker. We say reload config.
Sorry, maybe that, Ronnie, maybe that you already told. But what is exactly the meaning of rearm?
The rearm tells basically OpenNMS when is something reader in a normal state.
Ah, okay, okay. Okay, so
basically
there's the threshold of normality. Normal.
Exactly, yes.
Okay.
To tell someone, yeah, everything is fine now.
It means that if I configure an alarm that is related to the threshold overcome of certain events, I can suppose that when this measure come back to a lower result, I can gain a clearance.
Exactly, yes. Yep.
Ah, okay. Okay.
That is exactly what it means, yeah.
Okay. Very good.
That is exactly what it means.
Okay.
Yeah, I think the load value is probably not high enough here. Let's make here that threshold. I give you here an example in that tutorial here. Where is it here?
Running all this PDF and imaging so that you are showing there, the previous one was available in the session 5, right?
Everything is here in the session.
It's available on session 5.
Yeah,
correct.
Perfect. And also, like here's a threshold.
Very good.
So
okay.
CPU raw user, we can make that CPU. Yeah, as my browser's helping me here. We don't need a label because there's only one CPU raw user metric in the system. It's a node metric. And then, yeah, you can say now here like 50, rearm 45, trigger 1, save.
Okay.
See that here. Reload.
At the moment we receive events. What I want to tell is events. Then you have to configure alarms.
So yeah, I can. So let's see if we can get that. Oh yeah, here's because we have it set to 10 seconds. It applies pretty quickly.
Yeah.
So you see, there's already an alarm.
Yeah.
High threshold exceeded for the metric CPU raw user. That's what we have right now. Click on that event. Then you see the message is exactly like it's a node type metric. Basically everything what we've configured in a threshold. What was the measurement? 50.667. That made it exceed basically. That is the threshold, trigger, and the rearm value. When we stop it, And we need at least like 10 seconds, probably. So then comes the rearm event, right? And the alarm is cleared. It's now. And if you run it again, then 10 seconds later, it's raised. It raises again.
Okay. Okay.
Like with 10 seconds, it gets pretty quick. So if you collect them if you have like 5 minutes, there would be like 5-minute delay between the collections, right? So and then it's clear.
Can we put utilization value in the log message? I guess it's an internal variable, right?
What do you mean exactly?
Can we put utilization value 50.67% in the log message? So probably some variable what can be used in this case.
Yes. So there are like if you look into the event definition, that's basically what we do next. Like the threshold high, threshold exceeded. Let's see here. File editor, go into the events. I think it's some OpenNMS event. OpenNMS.
Sorry, where did you get the file editor? I never did it.
No problem. So the file editor is here in node info file editor.
Ah.
But you need to assign the role
The maximum
user.
role.
So you have to go to users first, modify the admin user or the user you log in with, and assign this role file system.
Wow, very interesting. Yeah.
So
thank you.
yeah, no problem. So that is, and then you have to log out and log in again, and then you will see the file system editor here.
Okay.
So OpenNMS connect D, is it not connect D? Threshold.
Default threshold events.
Default threshold, yes. Awesome, thank you very much. So you see here like these parameters all, that is basically evaluated for all the parameters available. So you can use them in the events as well. So you can rewrite the text if you want to. That is basically the same thing what you do with an SNMP trap, right? So you create the same event definition with the parameters for a threshold instead of a trap. So you can change these events
probably
if you
will be parameter threshold. No, parameter DS probably.
So yeah, so there's a that means like the that's the let's see here.
Oh no, DS.
Right, if you go here, configure thresholds here and SNMP. That is basically the data source.
Data source. Must be volume. But not.
And the parameters all give you basically just an output of all available parameters, or all the key value pairs. If you see that, if you look at the event again, so you see that here, like that's the key label node. DS is the metric basically. So instead of using parm all, you can say parm DS, and then it evaluates to CPU user, or you say parm description or parm value. So you can use all these, or threshold, trigger, rearm. You can use that as a key for the parameter if you want. So the parm all is basically just giving you all available parameters, like the key value pairs. But you can create your own event definition, which makes, yeah, can make more sense for you. So I think if you follow that example, just playing around with thresholds and that stress command, which is described in the tutorial here. So that is basically how you need to create the threshold. That's how you install that stress command in the Linux 3 system, and then you can trigger it by yourself. You can do pretty much the same thing in that stack. And then change the parameters, the event definitions, and then you can have a way to play around with these things. And I think that makes it a bit easier. So we have 12 now, but I want to mention something else because there was a request last Tuesday about REST API queries, right? I don't know who of you asked that question. There was somebody interested in making REST API calls against the measurements. So what I did here, where is it? REST API calls here. Yeah, REST API calls for measurements. That's in the README here. So there's a REST examples directory here. And there is a tool, I don't know if you use like Postman or something like that. There's an open source tool which gives you the ability to make REST queries, or like having like predefined REST queries against endpoints. You can install that on any platform. It's called Bruno. It's a tool, like it's an API client for your system, and it allows you to define your REST queries and save them on your disk for later use, right? So you don't lose them. And I shared, like in that repository, I shared my collection of REST calls with you. One is like, for example, getting the measurements for CPU. So you see that here, like that is the REST call. You make a GET request. You have to make an authentication with admin, and you can execute a query. And yeah, the node 6 doesn't exist here. Yeah, I have to look up the node here. What is the node 3? It's 4. So it's node 4. And then you get basically, you can make a REST call against the measurements and you get them back as a JSON output. And I did also some examples about like for provisioning. It also is some maybe helpful. So you can provision nodes with over REST as well. So if you don't want to create the nodes manually in the UI, you can execute that post command against the requisition, and that gets basically imported automatically. So if you send that here into the system, then you get all the nodes provisioned from over REST instead of creating them manually. I think that might be also helpful. And these REST calls or these REST requests are also in that same repository. You can load it into, if you download the tool, then you can load these REST call collections, and then you can play around with it as you like. Okay, then we went through data collection. We covered a lot of topics, I guess. Is there anything we so what is the topic for tomorrow? Have you do you know what Greg is talking about tomorrow in that session? Probably not.
No.
Not yet. Okay. So what Greg explained, he told me that he would like to add some possibilities like that. Getting this information on a Kafka topic might be one piece we talked about, which might be interesting for you, because like you really use OpenMS as a collector for all these metrics, and also like generating like maybe a threshold events or something like that, and just publishing them to the Kafka topic, and then you use your own tool to consume those events and metrics and alarms, probably, right?
Okay. And Ronnie, how many more sessions are still pending, or is it tomorrow?
I have to. I jumped in for Greg for these two. He asked me to do these two sessions on Tuesday and Thursday, because he was like he was really sick last week, and I had a call on weekends with him. So and I just said like I can fill the gaps here for these two topics. I have to speak with him what the plans are. I'm not super deeply involved in the organizational things.
Okay.
But I can talk with him. But it might be. I think it might be good to give you some time and figuring out where you would like to see some more insights. Where you, if you play around with certain topics, and then you notice, okay, I missed some steps here and there. Then I think collecting these topics, and then I think we can have a session afterwards to get you unblocked, or going more into details where you found yourself stuck. Yeah.
Okay.
And feel free and use the chat OpenNMS.com, like the community, if you want. In chat OpenNMS.com, all the community people are there. If you have a question about how thresholds work, or you need some help on certain places, there's also something where you can get help. Besides,
Sure.
yeah, if you need a bit, more direct help on just certain topic, then just drop a question in chat OpenNMS.com. The OpenNMS discussion channel. I'm not sure. Have you seen that already? I can show you that, how that looks like. Share my screen. Share the screen. So, do you see my screen?
Yes.
So chat OpenNMS.com. And then there's the public channel is OpenNMS discussion. So there are 1,600 people somehow available in the channel. Not all of them are responding, but quickly. But you can ask people asking various questions about troubleshooting and things like that. So if you just got stuck and you don't get any further, don't hesitate. Drop a message. Explain what you did, what you tried to do, and then people can help you quickly. Otherwise, it might make sense that you collect some topics your team is experiencing, and then we're figuring out how to address them. Maybe in a later session dedicated for troubleshooting, if you want. That's also, yeah.
Okay.
Okay, then I will sync up with Greg today, and if there's anything left, just drop it to Greg tomorrow, and then we will see how we can proceed with that.
Sure. Thank you, Ronnie.
Thank you. Have a nice evening, especially for the ones in Malaysia, and enjoy your day.
Thank you very much. Bye.
Thank you.
Have a good
Thank you.
one.
Bye bye.
Bye
Thank
bye.
you, Ronnie.